Okay, so we're going to start on the Malik 3 RSD file that we created. And let's do this. Let's do this also. Let's look at the PXRF data first, because I think we'll kind of do all this stuff together. And what I think we ought to do is make a copy of this, that we get rid of the quality control information from it. And then we'll put the PXRF data with the Malik 3 RSD data, and then import that into JMP and do some calculations with it. All right. So that's our plan. So I'm just going to copy it like we've done before. And then all I'm going to do is get rid of the stuff that's quality control stuff. So I'm going to delete some of the rows. Anything that's like not really relevant to the specific data that we collected, but it's quality control data that we'll assess or analyze later. And then what I want to do is make my labels the same as they are in this spreadsheet, the Malik 3 RSD spreadsheet. So all I'm going to do is just take the farmer description name and copy those to where it's in the appropriate location. So Costa Rica 1, 2, and 3 is called sterile. Costa Rica 4, 5, and 6 is called shaded. Costa Rica 7, 8, and 9 is called fertile 1. And Costa Rica 10 is called, and it looks like I spelled fertile wrong. Fertility. Fertility, no, the first one I spelled wrong, but the other ones I spelled correctly, which is weird. Okay. There. Bless you. Do that like that. Then I'm just going to get rid of my column that says farmer description. So I don't need that anymore. And just like so, this, I know it's stressful, right, when we're doing this together, and you're following along and trying to keep up. So after we're done going through all this, it's recorded, so you can go back and look at it. I will email you like the completed spreadsheet, so that once the data is all analyzed, like you'll be starting with where we ended up, or then going to JMP. Okay, so we'll all eventually, even if it like if you get stuck on something or you get behind on something, like you can follow along. If you want to go back and look at it and look at the recording of this, then you can do that. But I will email you like the spreadsheet with all the completed data. Okay, yeah.
Is the reason why it's called sterile? It's not like no copy.
Good question. So the reason why it's called sterile is it's probably a misnomer. There is coffee growing in that plot, but that's what maybe the translation of what the farmer called it. Right. So yeah, it's not like denuded of anything. Like it is producing, but not at the same rate as other places. And shaded isn't producing either. And that area is much more shaded than any of the other areas on the orchard. And then fertile 1 and fertile 2 are producing better than the other locations, according to the farmer of the site. Okay, so what I'm going to do now is just take the soil, lead, and cadmium data. And before I do that, maybe for the cadmium column, just so I don't get confused, I'm going to call this total lead there. And for the cadmium column, there's no cadmium, right? So I'm just going to get rid of it, because that's not interesting. So now I'm going to do is take my soil and total lead columns and copy them and paste them to the Malik 3 RSD. I'm just going to put them in columns D and E. And then what I'm going to do is check to make sure the soils match up or the soil labels match up, and I'm pretty sure that they do.
It still says fertility, with the,
Over there. It does, doesn't it? Tilly, thank you, Lee. So let's fix that. Okay, so besides that, I think we're good. So now what I'm going to do is just delete this column. Okay, so what we're going to do now is take this and I'm going to just import this into JMP, and we're going to have JMP do some descriptive statistics quickly for us. Okay. So the reason why we made our soil label like this is that JMP is going to assume that everything that looks the same is the same, right? And it's going to break it out by that. Okay. Sterile, shaded, fertile, etc. All right. Okay. So we'll have values for lead, cadmium, and then total lead. Any questions? All right. So what I'm going to do to start, yeah.
we don't need to.
Okay. So I'm just going to copy it. And then I'm going to open up JMP. And then, like always, go to File, New, and Data Table. And you'll open up a window that looks like this. And then you go to Edit and Paste with column names. So your data will go in. And then I'm going to save this somewhere that makes sense to me. Okay. So next thing, of course, is you want to check to make sure that your data were labeled properly, right? So soil is character data, and that's given by the histogram that's in red. And then the lead, cadmium, and total lead are in have the blue triangles, and that just means that it's numeric data, right? If it's not that, then if you double click on the column that has the data, you can change it, right? Here, you can change it to numeric and continuous.
Where did the fourth column come from? Which,
This one, the total lead. So total lead, total lead is from PXRF, and I just copied it from over here. When I grab this from that PXRF2 spreadsheet, grab this, copied it, and pasted it into the Malik 3 RSD. So why don't we change the name of that lead column that just has the lead in it to bioaccessible lead, because that's what it is. And then for cadmium, bioaccessible cadmium. Okay. Okay. And then most always we're just going to use the analyze or the graph menu. And in this case, we're going to use the analyze menu. So analyze, and whenever it's like descriptive statistics, it's tabulate, right? So analyze and tabulate. And we're going to put the soil, and you can play around with this, right? Like if you don't get it right, it's really easy to change it. I'm going to put soil in the vertical area, and then I'm going to put my bioaccessible lead, cadmium, and total lead in the vertical columns areas. So I'll just grab bioaccessible lead and move it up there. And same with well, let's do this first. we want coefficient of variation. So I'm going to grab CV, put it right there. And then I'm going to grab bioaccessible cadmium and move it right next to it, like that. And total lead and move it right next to it, like that. And it's by default putting in some, but I want coefficient of variation because coefficient of variation is the same thing as RSD, is relative standard deviation. So I'll just pop that in those places and it'll calculate the relative standard deviations for me. If you wanted other stuff, like if you wanted the min or the max or the mean, you could grab that too. And to do that, right, you just put it like right next to it, like that, and it forms that little blue square. I'll put in the mean. And that's the mean for bioaccessible cadmium there. So for here, I probably need to do it maybe right there. So that's the mean for bioaccessible lead and so forth.
Would you like us to add that?
No, you don't need to add that. Like always, if you want to save what you did here, you can go to tabulate and save script. You can save it to the data table if you want to. Why not? I'll save it to the data table, and you can also make it into a data table. So I could go here and it'll just make that what we just did into a data table. Okay. So I'll do that, and it just made it into a new data table, which I can then save it if I want to. Okay. Okay. So what we want to do then is, I'll just save it, I guess. Save it first. All right, so I'm going to just leave that open. And then what I'm going to do is go back to my Excel spreadsheet here. And I'm just going to put in my min and my max for the relative standard deviation. Because that's what I'm going to report in my data table that summarizes all of my QC duplication. So for lead, let's see. That's the one right there. So for lead, the CVs, for bioaccessible lead, the CVs go from, the lowest is like 2, and we're just going to take it to the nearest whole number. So it's 2 to 55%, right? And then for cadmium is 13 to 44. And you can do the same thing for the total. Looks like it's 7 to 22. I got some zeros in there. I do. Oh, you're right. Oh, wait. Yeah, I do have some zeros in there. So I'm trying to figure out though, is that in locations that I don't have data for? So those BTSS for total, I probably do, huh? Okay, so you're right. I'm sorry. Thank you for reminding me of that. Yeah, so it's 0. The lowest is 0. But perfect precision for some of them. Some bad precision for others. And the reason why we got bad precision is because the levels are low, right? And so when we're close to the detection limit, it's very difficult for the instrument to accurately measure what's there, and therefore your precision usually goes down. So we were almost all of our analyses were working at the detection limit for lead and cadmium for bioaccessible for MELIC 3. Okay. Okay. Any questions about this, about what we just did? Okay. So this takes care of our duplication information at the method level for everything. Let's go back now and do some of the calculations that we can do for PXRF, because we haven't done much of that yet. So I'm on the first PXRF tab or worksheet. And we have a calibration for lead and cadmium, and the only information that we get from the PXRF is whether it passes or not. Because the calibration is based upon an internal calibration that is set up by the factory. And so it passed. So we assume that it's good. And then this first analysis is analogous to an initial calibration verification, or an ICV. So I'm going to calculate a percent ICV for both lead and cadmium, and percent ICV for lead and cadmium is the measured over the known, right? And so what's there in those lead and cadmium columns is the measured. The known values are down here. Okay. So we'll go equals the measured divided by the known. And be careful, because I put these in an order that's different than they are up here. And that was dumb of me to do that, but that's what I did, and I'm sorry. Okay, so we want to compare it to the right thing. And then I'm going to do the same thing for the cadmium. So this first one was for lead. This next one is for cadmium. And we'll say percent. And then what I'm going to do is I'm just going to copy that formula. But before I copy that formula, I am going to make it always go back to cell D30. Right? And you remember how we did that last time? You know that, right? $sign in front of the letter and in front of the number. And I'll do that for both of them. And what I'm going to do is take these formulas, copy them, and paste them down to the next place where I have SRM 2711A. So I'll just paste them there, do it at the very end, paste them there. Okay, so the first one is percent ICV recovery, and the second ones are just recoveries of standard reference material, right? 2711A. Standard reference material 2711A is a moderately contaminated soil from Montana. All right, so if you looked it up on the NIST website, it would tell you that's what it is. So it's a soil sample that we purchased from the National Institute of Standards and Testing. They gave us this jar that's homogenized that a lot of labs have analyzed, and we have known values of different materials in it, notably lead and cadmium. Then we have the PXRF scan it. So when we talk about this, this will be percent recovery of standard reference materials. Okay. Okay. I don't think we can do anything else. I think that everything's good on that. So what we're going to do now is summarize the quality control information that we have at the instrument level and the method level for MELIC 3 or the bioaccessible extraction, and then we'll do the same thing for PXRF for total at the method and at the instrument level. Okay, so we'll just do them, and then after we do that, I'm going to have you summarize your data into data tables. I'll give you a little bit of time to do that today. Not a ton of time, but I'll give you a little bit of time to work on that today. to create your own quality control tables. And that, I think you have time to at least get a great start on that today. And then that will be due a week. Well, it'll be due on the Monday that you get back to school. Okay. So I'm going to have you, but the plan is to have some QC tables that you'll have mostly organized, and also to have some actual data analysis of the cadmium and lead data. And we'll use our comparative tools in the graph builder, and makes a histogram with connecting letters report associated with it. So that's where we're going. Do you have any questions about that? Okay. So these are in milligrams per liter. We need to convert them to milligrams per kilogram, just like total lead we have there. So what I'm going to do is I'm going to create 2 new columns, and one is going to be called bioaccessible lead, bioaccessible cadmium, but the units this time are going to be in milligrams per kilogram. And it's still parts per million. It's just on a mass basis instead of a volume basis. Okay, now I'm going to ask you this question. What do we need to do, or what information do we need to convert volume to a mass basis? And it's always the same. Soil dissolution ratio, right? That should be the first thing that comes to your mind every time when you're working on lab calculations. So what was our soil dissolution ratio? And if you don't remember, and I don't expect you to remember, it's in your
3 to 2 plus or minus 0.2 grams.
So like Liz said, it's in her lab notebook, right? She just looked there, and it's 20 mils of solution, 20 mils of Malic 3 solution, 2 grams of soil. So if we're going to do that conversion, we're going to start with the quantity that we have on a volume basis and just convert that to the quantity that we have on a mass basis. We'll start with the lead one. For the sterile soil, it's 0.1343. 0.1343 milligrams of lead per liter, and we need to convert that to milligrams of lead per kilogram of soil. Our soil to solution ratio is 20 milliliters to 2 grams of soil. What do we do? We need to get rid of liters, right? So what needs to go in the numerator here? Volume, right? 20 mils, 2 grams, and then just convert 1,000 mils, 1 liter, and 1,000 grams, kilogram, and you'll see that these all cancel out. Wait a second. Problem. I went too fast. How about I'm right? But I did get ahead of myself. Okay, so that becomes 10. So all we got to do is just multiply our quantities in solution by 10, and that'll take it over to parts per million on a mass basis. Any questions? Seeing none. Shannon.
Not to do anything with our milligrams of lead versus 2 grams.
Well, this is milligrams of lead and this is grams of soil, and we want to end up with kilograms of soil, right?
Oh, okay.
Yeah, I'm sorry I didn't put the kilograms of soil, but yeah, we want to end up with kilograms of soil. Okay, so we just multiply all those things by 10, and then we fill it down, and then we're done. All right, you good? So now what I'm going to do is create yet another spreadsheet. Okay. And so I'm going to take this one and copy it. And we're going to, you call it whatever you want. Call it. Put it wherever you want. All right. So these values here, right, are linked to a formula. And I need to rearrange them. So what I'm going to do is take these and copy it and paste them just right next door to them. But when I paste, I'm going to do a paste options here, and I just want values. Okay. And then I'm going to get rid of these ones that I was just working on. And I'm also going to get rid of the lead and cadmium in solution. And then I'm going to get rid of that stuff down there, the min and the max RSD, because I don't need that anymore. Now, what I want to do is the following. I'm going to create a column for soil and then a column for the method of extraction, right? So I'll have a column for soil, column for method of extraction, and then a column for the amount in the soil. Okay, so I have 3 columns. So what that means is that I need to, and I want to organize this so that I can pull out my Los Osos soil and I'm just dealing with the Costa Rica soil. I also want to do that. So a good way to do that is use the sort and filter tool. So I'm going to sort and filter on soil. So I'm going to select the soil column and I'm going to go to sort and filter right here. And I'm going to sort alphabetically using the sort Z to A. Okay, so try that, see what you get. So we got sterile, shaded, and then we got our Los Osos soils and our Holland soils. And then we got fertile 2 and fertile 1. And so what I'm going to do is pull out my Los Osos and Holland soils by just selecting them, copy, and then I am eventually going to just get rid of them, but I'm just going to paste them over here somewhere, right, just to the side there. And then I'm going to rename them to here. I want to do that. Let me think about this just for a second. Yep, that's what I want to do. So I'm just going to replace these headings. Okay, now what I'm going to do is get rid of, right, that's a problem. So I'm sorry. Apologize for doing that incorrectly. So I'm going to just move it right now down here. Okay. And the reason why I'm going to move it down there is because I want to get rid of this now. And then let's make it so it's sequential. So fertile 2 is after fertile 1. So I just grab my fertile 2 or selected my fertile 2. I'm going to move it below fertile 1. And then I'm going to get rid of the cells that I did there. Okay. And then what I'm going to do is I am going to work on making my my columns properly. So to do that, I'm going to insert a column here right after soil. And I'm going to call this column method. And my methods are going to be as follows. We could do total first. Let's do total first and copy that and paste it here. And then, okay, and then I'm just going to fill that down here like that. Okay. Then what I'm going to do is I'm going to take my soil names, stale, shaded, fertile 1, fertile 2, and copy that and paste it just below like that. And then I'm going to do bioaccessible lead. That title, paste it there, and then fill that down for all of those. And the reason why we're doing this, there's a method to this, is because this is a format that JMP will readily be able to use to summarize the data for us. So we're going to do the same thing with the bioaccessible cadmium. So again, I'm going to select my data or my soil names, do it one more time, and then do bioaccessible cadmium. Fill that down like that. And then I just need to move the numbers. So at the end of the day, you should have something that looks like this. And if you don't worry about it, because I'm going to send you an email right now that has it summarized. Okay, but my point in all this is that, like, you've gone through it once and you've seen it, and so you have an idea of how to do it. Let me just find that email. There it is. Okay, so I just sent it to you. It has a spreadsheet that has that data on it there. And it also has another spreadsheet that summarizes all the information that we've collected all quarter for the Costa Rica soil, including that summary cadmium and lead data. Okay. And that spreadsheet, let's see where it is. There it is. So it looks like this. Okay. There's two worksheets, summary, all data, and then cadmium and lead data in that email. So you can grab that and open it up. And if you want, you can save it to your device. So you got it. And we're going to use these data to make some interpretations. All right. The order might be a little bit different. I can't remember if I have it in the same order or not, but it's all the same data. Okay. Any questions? So first things first, we're going to import data to JMP. And the data that we're going to import to JMP, we're going to start with the cadmium and lead data. I'll talk about the summary, all the data later. But we're going to do soil, metal, and milligrams per kilogram. Oh, I'm calling it metal. Let's call it method. So I can do soil, method, and milligrams per kilogram, and copy that. Go to JMP. And open up a new data table. And then paste your data like you've done before. Paste column names. Make sure soil and method are character data and milligrams per kilogram is numeric data. And then, of course, before we do anything else, save it. So what we want to do is we're going to do a couple things. First thing is we're going to graphically look at our data, and then we're going to analyze it using a model and using the Tukey HSD test, right, to see which of our populations are different from each other. So graph builder is under the graph menu. Are you all good? Yeah. All right. Graph builder. So you'll have this come up. We're going to put soil on the x-axis. We're going to put as our response variable milligrams per kilogram there, which is concentration. And then over here in our legend, where it says milligrams per kilogram right there, we're going to put method. Okay. And then I'm going to summarize it with a histogram like that. And we can't see cadmium, right? We can't see bioaccessible cadmium because it's so low. So any suggestions what we can do with the y-axis? Make it so we can see it. Like what we'd adjust with that scale. Yes, we can do log. So if you move, right, anytime we want to change anything, a lot of times the pointer is going to turn to a hand. So when it's a hand, we can right click on it and do axis settings. And instead of the type being linear, we're going to do log. And let's see. Let's also, while we're here, let's change the font of the axis label row, and also we don't have any reference lines, so don't worry about that, but let's change the font of our axis label row to something that's bigger than that and bolder. So bold, and we'll make it 12 and say okay. And then you can go okay. That's not what I wanted. Well, that's good enough. Notice the scale goes up to 7 and it kind of cuts off some of our data here. So let's go back over here and right click on it, go back to axis settings and make the scale go up to like 10. Okay. So that's better. I think that's still not quite enough. So I'm going to change it to go a little bit higher. Maybe I'll change it to 12. So you can see it because I'm going to put in some error bars. Right. So conveniently, right, like we have data that is pretty easy to visualize. Bioaccessible is cadmium's the lowest, then bioaccessible lead is next lowest, and then total lead. The axis makes it a little bit like tricky to see the actual differences because it's on a log scale. So there's a factor of 10, right, in between each of the whole numbers. So that makes it a little tricky, but that's the best we can do so we can visualize the cadmium data. I might want to change the order of these to go from low to high, even though they're kind of similar. We could leave it too, because they're pretty similar. But I'm going to put in some error interval. So where it says error interval auto, I'm going to change that to standard deviation, like that. Okay. So there's other things you can do, right, to make this look nice. But to do that, right, you just go to the thing that you want to change and you can right click on it, right? Like I want to change the milligrams per kilogram. I want to change what it's called, but I also want to change the size. I want to change it bold and 14. There we go. And then I want to change what it's called. I want to call it concentration. And in parentheses, I'm going to put the units. That. And then that works for soil. So I'm going to leave that like that. I'm going to drag my legend up over here. And then, right, you know what to do. Just do your stuff, make it look nice. Okay. So while the next thing that we're going to do, though, is we are going to do a model analysis where we're going to compare statistically the columns to each other. Okay. Any questions, though, before we do that? Yeah, Anna. Okay, so what we did is it's a y-axis. So I'm moving my cursor over to the y-axis, becomes the hand, the palm. I right click there and I go to axis settings. And then from axis settings on the far left where it says scale and type, I'm going to change it from linear to log. You're welcome. Okay, so I'm going to save this, the graph builder on that little red triangle by graph builder. I'm going to save the script to my data table, just so it's there and I don't have to make it again, even though it wasn't that hard or long. And I'm going to leave it open. Okay, just leave it open. And the next thing that we're going to do is do an analysis of variance, right, to look for similarities and differences in our populations. Okay, you ready for that? Yeah. All right. So let's go back to the original table here. And let's go to analyze and fit model. And for our response variable, what is it? Close. It's the, yeah, milligrams per kilogram. And then we want soil and method. You're 1 out of 3 chance, right? Soil and method. We want to, I selected both of those using the control key. If you didn't select both of them, it doesn't matter, right? But I'm going to add them down here. And then I also need to cross them, right? Put the soil and method together. So I'm going to do soil and hold down the shift key and method and then cross it like that. So I should have 3 independent variables down there: soil method and soil times method. So I select one, hold down the shift key, select the other, and then click cross. Then, are you ready? No. Okay, let us pause. You all ready? Yeah. Yeah. Someone said no, though. They're just screwing around. You're ready? Okay. So run. And what we care about is the soil method, the cross. So we do the drop down arrow again, and we go to LS means Tukey, HSD. And we are going to then get rid of this big table right here because that's summarized in the connected letters report down here, right? So this doesn't do anything for us because it's summarized there. And so I'm going to click on that red arrow next to LS means differences Tukey HSD and get rid of the cross tab report. So that's that. And then I want to, just so I don't need to go back and do it again, I'm just going to go where it says up here, response milligrams per kilogram. I'm going to click that drop down arrow and go to save the script to the data table. Do that. And then I'm going to take this stuff right here and have make a data table out of it for me. You don't have to do that, but it's going to make it easier for us in just a minute. So here I'm going to say save connected letters table, right? Save connecting letters table, and it's going to do that, which is what I want. And now we need to label in our original jump data table with these connecting letters, right? And so I'll go over here to this and then open up. Oh, I don't want to do that. Open up my connecting letters table here. And here's something that I learned, which I should have learned a long time ago, and I'm sorry. You only need to put the label in one of the rows. So remember before, for everything that's sterile, bioaccessible lead, we would put the connecting letters in every single one, right? We only need to put it in one. You know what I mean? Maybe you don't. Anyway, go here into this column up here and double click on it and call it label. And we want the label to be character data in nominal. and then you click apply and okay. And then before we do anything else, right click on it now and label it. Label it as the label. You know what I mean? Label it as the label. And when we do that, you'll see that over here on the left, you have the label column with a label tag next to it. So that will tell Jump that this is what we're going to use to label our columns. You want me to do it again? Okay, so double click on it, cancel, double click on it, and you can change the column name to label. And then where it says data type, you got numeric, character, row state, expression, you want character. So you click character and then click apply, and then okay. And then we label it, yeah, Shannon.
For the bioaccessible cadmium, there was like a 0. We're supposed to delete that.
Oh, good. So here we got that value, just leave it. No, is that the one you're talking about?
Yeah. Is that 0 or is that dot?
That is no value. So we leave it as a dot. Because that just tells Jump that there's no value in there and we mean it to have no value in it. So it just doesn't use it in its calculations. Okay. So now I'm going to bring back up my connecting letters table here. And what I'm going to start doing is just copying the letter. So the first one, fertile 1, total lead, fertile 1, total lead. All my total leads are down here. You only need to do it in one spot. Maybe I'll do this too, so they stay there. Go. Oh, there it is there. There it is there. So as I said, you don't need to put it in every single cell. Right. Fertile 1, total lead. Oh yeah, it's A right there. A. And then next one is sterile total lead. Sterile total lead is AB. So let's see, I'm just putting it in one of them. And then, you know, you just keep doing it. Okay. And then when you're done, I'll remind you how to put them onto the columns. All right, you good? Probably way faster at that than I am. All right, so our label column is labeled label over here. And then what I'm going to do is go back to my graph here. And where it says label, no labels, I'm going to go label by row. Label by row. And magically they appear. So you can drag them up. Okay, so you can see them. So columns connected by, or columns with different letters on them are significantly different at P of 0.05. Or P of less than 0.05. Are you good? Not good. What happened? Just put a bunch of, okay. So if it didn't work, probably the labeling was maybe wrong.
You're supposed to do it in column.
So if you go back to your original summary spreadsheet here. Oh, what I would also suggest, of course, is now that you've done that, you go to that graph builder arrow and save the script again. Okay. And then make it look nice, right? I'll create an assignment. I'll make it available. I'll do it before tomorrow. I'll probably do it while you're taking your exam tomorrow. And if you have some questions about it, you can ask me. All right. But if you had trouble, let's go back to this spreadsheet and figure out why you had the trouble. Is your label here marked label down here? If it's not marked label down there, then select it and right click, or select it, right click on it and go to label. And you know it's the labeled one because it'll have the yellow label tag next to it. Why is mine so small?
The legend.
Yours is big? I want it to be bigger though.
Yeah, but it goes over the top of the font.
If it's too big. Okay, so if you want to change it, you just double click on it. Right, and then you go to font here. You all good? All right. Lee.
You want the y-axis to have all the numbers, like they'll make it look better.
You can make it, I don't like that too much, but maybe it might help a little bit, especially for where it says between 1 and 2, because that kind of gives us an idea of the magnitude for this one. So try it by just doing well, if you just do the big numbers, 10, 1, 0.1, 0.01, and so forth, then you miss this, but I think it's okay. If you just have the major ones, it probably looks nicer. Yeah. So I'll create, like I said, I'll create an assignment with the details. But the assignment is just going to be the QC tables and this figure. Okay, that's it. Before you go though, let me just show you, if I go back to the summary Excel file that I sent to you, summary, all the data. So this is all the things that we have done for the Costa Rica soil summarized together. And what we're going to do when we get back, just kind of to leave you on a positive note and a cliffhanger for what we're going to do, that's going to be pretty cool, is we're going to see if there's any type of relationship between what the farmer classified the soil as and any of these parameters. See if it makes sense from a soil health, soil chemistry perspective. We'll just use jump to do that. It'll be easy. You'll like it. All right, that's it for today. I got an office hour now. If you have some questions, feel free. We'll meet in here in the lab next door for the exam tomorrow. The window is 9 to 12. Okay. You can use any of that time, all of that time, doesn't matter to me. Yeah,
Really?
really.